Hi, my name is Max.
Hi, everyone. I'm Natalie, and we're so excited to have you here today.
So a little bit about myself. I'm a tech lead at Babylon at data science and analytics platform. And my interests include infrastructure, data, and machine learning.
And I'm Natalie Godec. I'm a cloud engineer in the Data Platform Foundations team. I love all things infrastructure and have a particular thing for security. So overseeing our data platform really allows me to draw these passions of myself. And two words about Babylon, who we are. We are a digital-first, value-based healthcare company, and we're on a mission to bring accessible and affordable health service into the hands of every single person on Earth. Now, that's quite a challenge, right? And as you might imagine, as a healthcare company, we deal with loads of sensitive data. The data needs to stay secured and protected at all times, while also allowing us to innovate and create products that will bring us down the road of our mission. Our security policies tend to get very complicated, and we often find ourselves challenging the limits of our cloud providers and our product providers of the technologies that we use. And on that, over to Max to introduce you to your very complex security policies.
Thanks a lot, Natalie. A lot of companies have seen the benefits of using cloud for everything from storing data through running microservice infrastructures to machine learning and so much more. But once you store your data in the cloud, all the APIs that protect it are public. Natalie already explained what our mission is, and while we're fulfilling it, we cannot compromise security of our members' data. We cannot keep the public APIs public much longer. So how do you do that? Most of the things we're going to cover today are going to talk about our adventure with GCP, but these concepts are not foreign to other platforms, and you will be able to take anything that you've seen here and adapt it in your own context. Number one, let's take a look at a sample request hitting a public API. We need to make sure that we consider every single aspect of these requests. In a classic RBAC scenario, a user makes a request. We check the identity of the user, and we compare it against a list of users that should be able to access given resource. But what if your resource is in the US and data sovereignty laws prohibit any UK employees from accessing it on UK soil? We need to make sure that any policies that our legal, compliance, privacy, and security teams craft can accommodate these sort of nuances. And it isn't uncommon in the world of healthcare to have many vastly differing regulations that across borders will tell you that the data of a citizen of one country need to be processed in a certain way that is different to data of a citizen in another country. If you thought GDPR was bad, this stuff can give you proper nightmares. Some of countries will have very prohibitive laws, while others will allow you to be a little bit more adult on your own. We wanted to make sure that we don't just comply with the rules we're giving in any given country. We want to make sure we act in the spirit of the regulation. If the regulations want us to make our members' data secure, we can't do the bare minimum to make that happen. We will do everything we can. So instead of considering just the identity and the role of the user, we want to take a look at as many things as we can, including, yes, the identity, but also things like where is the request coming from, what kind of data is being requested, as this might affect when we should say yes and when we should say no to a request coming in. We also want to know things like intent, as data might be available for one purpose, but not another. And finally, for instance, auditing purposes, we want to be able to tell why was a permission granted in the first place. So let's start delving into the resources that you can create to make all of that happen. First up, using good old IAM. But already here, there is something that if you are not doing it right now, you should start as soon as possible. Because the way you can grant a person a role is made so easy. It's an absolute miracle of modern cloud APIs. But even in a simple example like this, you can already start encoding some additional information about, for instance, why was the role granted in the first place? And very importantly, when should the permission expire? Because if you give somebody a role with indefinite duration, at some point, somebody will forget that that role was granted and that the user had it. This complicates the entire security infrastructure and reasoning about it. And so again, if you're not doing this, this is one of the simplest things that you can do that will remove a massive chunk of your potential attack surface. Because of all that zombie users that have access to data that they don't even use can be used against you. Moving on. In the same spirit, let's say that a user actually needs access to some data set. So we want her to get permission. But does she need access to all of the data? Most of the time, no, she doesn't. And what's more, she shouldn't. Raw data, especially in healthcare, can be avoided to be seen. And that's a big story for a completely different time. But in this session, I'm just going to show you in a very simplified example how you can manipulate the data dynamically when the user is requesting access. And yes, you can do this by creating a new data set that is maybe anonymized and so on. But that means that you have to have all of these data sets ready. You have to predict what the user is going to want to see, what the regulations allow them to see, etc., which, to be honest, arguably is not the job for data engineering teams. All of that can introduce delays, and delays cost money. And in some cases, they reduce security as well. What you can do instead is to mask the columns or even rows dynamically so that the final data set that the users get to see includes all the data that they need to do their job, but it doesn't include anything else. And so now, if somebody tries to attack you, they won't be able to target any of your zombie users as they do not have indefinite permissions. But even if they get access to somebody potentially senior, the data that they see is going to be relevant only to the particular task that the senior person is doing right now. The third thing I'm going to mention is Google's VPC access controls. This can be trickier to implement without that particular API, but you can do it using other tools like VPCs or firewall rules. Service perimeters give you direct control over who can access which APIs and in which context. And that's massive because as I've mentioned before, giving one user access to a particular data set is not enough, as when UK employees working from US office, even though they retain their original identity, I mean, nobody really changes their login credentials while crossing the border. In that case, they should lose access, as it might be a massive violation to access UK members' data on US soil. Access controls give you the power to make these nuances enforceable. We can now very easily say not only that the user has access to some data, but also where from. This is the customary visual aid for all the folks that are more visual in the audience. And so now you can take all of these small things, which can and often are managed in different ways in different places, and you can really just make them one quick and simple process. A user submits a request to access data, which can be done very easily through Git. Then in a CI/CD tool, we can get the full context of that request and validate it. Potentially, we might have to intercept the request and edit it in some ways, like for instance, removing a user if they don't satisfy our policies, or changing which IPs the data will be accessible from depending on what the data includes. And then we orchestrate all the cloud resources using Terraform and TerraGrant. End-to-end in potentially 5 minutes. So when your users are asking for access to data, you can very quickly tell them what they can and cannot access, and then give them their own private Google project or Kubernetes namespace. This is how a sample policy might look like. It can really be just a simple YAML file that lets you specify which attributes of data and users can go together and which don't. Some of these fields will depend on your organization, and you should really make it as custom fit to your needs as possible. This is a very simplified version of something most of companies might want to codify. In this particular case, we're looking at a dummy policy, which allows access to raw cities and diseases in UK, as long as the patients they refer to have given an explicit AI learning consent by any UK-based full-time employees with enhanced DBS check if they wanted to use it for AI model improvement. The access is also going to happen through a virtual desktop infrastructure because the data is raw, and there is going to be no internet access. Now, any teams that need to make these decisions can get involved, directly impacting how the data can be accessed across the organization, but without ever having to talk to engineers or getting familiar with the data. And from our user's perspective, this is how a sample request might look like. I want person 1, 2, and 3 to be able to access this particular table but only the rows that were consented for and with dynamically masked columns in this particular way. In addition, my project is going to expire on 1st of July 2021. The data is going to be used for AI model improvement, and a reason for approval and maybe description of the project is included in Jira ticket Jira 123. And all of that is a direct input to a Terraform module that can then take all of the resources I showed you before and many more and provision them together so that all of the complexities are hidden from people that do not need to see them. As I mentioned before, in the CI/CD tool, we're going to then enrich the request with all the metadata we need to make the decision based on policies, and then we can directly compare the two. And that's me. So now let's see what Natalie has prepared for us.
Thanks, Max. Right, so now you have seen how to analyze your requirements in terms of security and how to construct a policy that will be flexible and will encompass all of the needs that you have in your organization. Now it's time to shift the focus onto what happens after. You see, when you use a cloud platform, all of the requests that happen and all of the events that happen within it are API requests, and each API request produces a log. Logs contain masses of very important data that you definitely should store centrally and use to produce insights, analytics, alarms, and have a really good visibility onto your platform. Now, I will continue using the example of GCP, but you can apply the same principles whichever platform you use. In GCP, each resource in each project will produce a log, and you can use something called logging sinks to route those logs into a specific location. These logging sinks are just log pipelines, and if you use Logstash or CloudTrail or anything else, you will likely have a similar pipeline. Now, I would suggest that you would want to have your logs in a central location, such as a centralized logging project, in order to enable the analytics later down the line. And this is quite easy to set up until you start having VPC service controls and service perimeters. You see, when you have your data that is sensitive, you will want to protect it with service perimeters like Max described. But also logs are sensitive data as well and specific to your organization. So you will want to have a service perimeter around the logging project too. And then you start having an architecture that is quite complex with some projects within different service perimeters, others outside, because not all services have to be restricted. And then the logging projects inside perimeters too. And how do you enable communication, since the perimeters serve for this particular purpose of not allowing any data to go outside of it? Well, you can use egress rules to allow specific data to go into a specific place. In this case, let's say that we want the logging sink to route the logs from our project A into the logging project. And the egress rule will say that the logging API is allowed to exit the perimeter if the data is going into the logging project. And then on the side of the logging service perimeter, you will want to say that the identity of the logging sink is allowed to enter data inside the service perimeter. Whatever logging pipeline you use, you will have an identity of this pipeline, and this identity can be used to set up IAM roles, permissions, and also network traffic rules if your platform allows for that. And this is exactly what we're going to do with GCP. We're going to allow the traffic with the logs from the originating perimeters to exit if they are going into the logging project, and also allow the logging sinks to write into the logging service perimeter. In order to make this setup automated and a little bit more simplified, you will want to consider having top-level folders in your organization. In general, the more high-level your setup can be, the better, because then you can just set up the logging configuration on the top level and forget about it, and everything else inside your platform will be already covered. But maybe you have a requirement to store logs separately, depending on the environment, maybe non-production, production, maybe location, or maybe department needs to be stored separately. In that case, you can say, okay, let's have top-level project folders that signify those separated spaces, environments. In this case, I will use an environment as an example, production and non-production. Then we create a folder logging sync, and we'll say that all children are included in the logging sync. And we create separate spaces for storing those logs to comply with the different data locality or storage requirements. Each of the logging syncs, again, will have a service account, its writer identity that will be used to set up access. If we look at this architecture in a little bit more detail, it will look something like this. You have your GCP organization, and you enable audit logging on all services. This is what is going to give you the most data. Then you say that you have top-level folders, for example, production, and all of the projects that go underneath will have to live within folders or underneath just the top-level folder. Then on the right-hand side, you create the audit log prod project, which will, for example, contain a BigQuery dataset. And we create a folder logging sync from the production folder to this BigQuery dataset to store logs in BigQuery. Why BigQuery? Well, because it's a data store that is extremely scalable and enables you to do analytics that we will take a look just in a second. Whatever service perimeters you will have around your source projects will have to have an egress policy. That egress policy will allow logs and BigQuery API to go outside of the perimeter into the logging project. And on the side of the logging service perimeter, you will have an access level, and you will add an access level condition for each of the logging sync identities, and also an IAM role for the identity to write into the dataset. And everything will be encrypted end-to-end thanks to GCP, encrypting everything, all data in transit, and us using a service identity, a service account identity. When you use Terraform, you can actually simplify the setup and make it nice and automated. You will have a module. Terraform allows you to create a module which groups resources that have to be deployed together. In this case, we have seen that we create a folder logging sync, a BigQuery dataset, an access level condition, and some IAM permissions for the identity of the logging sync to write into the target dataset. That will be our GCP folder module. And then you code it in a way that in the input variables, or TerraGrant if you use TerraGrant, you will just have a list of folders that you want to create. And you might want to have a flag that says that a folder is audited, or maybe logs enabled, something like that, something descriptive of saying that this folder is the top level folder where the logging syncs will be configured. And then, of course, the module will create your folder and create all of the logging configuration for you. And then you don't have to worry about anything else. All of the projects that will be created underneath will be covered with the logging syncs automatically. And when you need a new folder, you just add one line in the input. Very simple, very nice, like that. Now, I've mentioned a couple of times the BigQuery, analytics, querying. What do I mean? What if you want to see who accessed your data in production? How do you do this now? Is it easy to do? Do you have to go and search somewhere through the log trails, or maybe some specialized security software? Well, if you have your logs in the central place in a store that is queryable, you can have a really simple query like this and select user emails from Cloud Audit data access. In this particular case, this is a Google Cloud logging table that contains all of the data access logs. And you might want to filter it by resource or email or time zone or region. Or maybe you want to see policy violation statistics across your entire platform. So you've written all of those policies and now you want to monitor them. This particular query actually comes from a really cool Medium blog post that describes how to create a dashboard about VPC policy violations in GCP. And this really just gives you all of the data that you need. Now, you can't really set up real-time alerting on this because logs come in not in real time, but every hour, I believe. But this will still allow you to create really nice visibility and really nice dashboards across your platform and understand who is trying to access what, where they're not allowed to, which regions might be affected more. Maybe there are trends in violations and you need to kind of keep that in mind. And the third thing that I want to show is usage statistics. Now, this query starts to get a little bit more complicated, but fear not, it's actually really easy. You can take, for BigQuery, for example, you can take which user has queried how much data per day. And then you can create dashboards like this. Now, all of the numbers here are randomly generated just to illustrate the possibility to you, but you can actually classify your usage and the costs of each project, or per region, or per GCP project, see the stats and the differences between usernames. And this starts to get really, really interesting when you start comparing this data over time. So you can see how much the usage of your platform is growing, for example, or which project and which team is being the most active, or maybe which query or which analytical project is starting to cost a little bit more than expected. And this kind of data really will allow your analytics teams to be more independent and to optimize the way they work, and really have a good visibility into what they do on the platform. And so this is a BigQuery usage example, but similarly, like all of your logs contain so much data and so much insight that you should really, really think about using it and building some dashboards that are useful for your company with that. And that is all from us. If you have any questions, we're really happy to answer them. And would also like to say that we're hiring. Thank you very much.